All right, looks like we're a little bit after the top of the hour here, so I'm going to go ahead and get things started. My name is Keith Sherburne. I'm the chair of the AMS Board for Operational Government Meteorologists, and on behalf of the board, I'd like to welcome you here today. Got a small crowd, but I'm sure we'll have some good discussion after this talk. It's my pleasure to introduce Brett Borchardt. He's a meteorologist up at the National Weather Service in Chicago, and he's a bit of a subject matter expert when it comes to communicating probabilistic information. He has a great, well, it's not a one pager, it's a several page little guide on probabilistic messaging. And he'll get into a little bit of that today. And I'll let him introduce himself further. But Brett, I'll let you go ahead whenever you're ready.
Sure. Thank you, Keith. And thank you, everyone, for joining on a Friday afternoon. Nice Friday afternoon for different parts of the country. It's in the 60s here today. And thank you, Keith, and the AMS board for inviting me to talk this afternoon about a topic that I'm really passionate about. It's communicating hazardous weather. And Keith mentioned a one pager or several pager. I actually have a link to that at the very end of the presentation. So hold on to the edge of your seat. You'll get to have it there. And as you mentioned, I'm a forecaster with the National Weather Service office in Chicago. Started my career at the National Weather Service in Marquette, and then I worked at the Grand Rapids office before coming to Chicago. And feel very lucky to be working where I'm working and to have met Keith beforehand. We are actually in the same research group in grad school. So without further ado here, let's talk about word choice. And to do this, we're going to start off by looking at a picture of peppers. It may seem like out of left field here, but what I want all of you to do is looking at this picture of peppers and your own knowledge of different types of peppers, maybe your own experiences of eating different types of peppers. In the back of your head, see if you could figure out sort of what spice level you would give to these peppers. Would you say they have no heat at all? Maybe they're mild, medium, hot, or extreme. Where would you categorize, or what would you categorize the spice level of these peppers? And as you're thinking about that, I want to remind all of you who aren't aware, there is actually something called the Scoville scale. I think I'm pronouncing that correctly, but this is a scale that's used to assign the rating of spice level to different peppers. And it ranges from 0 to as high as 15 or 16 million, which is pretty extreme. And with the knowledge of the different levels, I have a few peppers on there roughly where they should fall. I'm wondering if we could now put those same words, no heat, mild, medium, hot, and extreme, and where we should put them on the scale here. That's the next question I want to pose to all of you. Would it make sense to have them sort of evenly distributed, sort of linearly distributed? If you look at the numbers I have on the scale here, you see it's not linear at all. It's more logarithmic actually. So maybe it makes more sense to skew the scale toward the left, where we have extreme somewhere in the middle. Maybe your own personal like spice tolerance level is a little bit different. Maybe you've been eating spicy peppers your whole life. Maybe you're from Texas or something. I don't know. I can't handle spice myself, but maybe your own tolerance level looks something more like this, where you don't feel any spice till you eat jalapenos. And by the way, those were jalapenos in that picture there. What's the correct answer here? Where should we put these different words? And who's to say any of us are right or wrong? Well, the thing is, even if a phenomena like the spice level of a pepper, but different type of phenomena like in meteorology, even if they have a well-established definition, our own experiences or thresholds actually mold our estimations of intensity. And because of that, we all have sort of different answers and different thresholds. So let's say we're forecasting the spice level of a jalapeno. So I work for the National Weather Service. Let's say for this afternoon, I'm working for the National Pepper Service, and I'm forecasting the spice level of a pepper here. What would be the correct spice level? So let's say the forecast is for 12,500 SHU. Okay, so maybe person A says that's not spicy at all, whereas person B says, oh my God, I'm dying, that's me. But maybe, sorry about that for popping up here, maybe it's better to talk about probabilistic information. The National Weather Service is heading towards using probabilistic information in our messaging going forward. So maybe we should throw in the IQR, the 25th to 75th percentile SHU on there. Maybe it's 8,500 to 14,000. Better yet, why don't we show the probability of exceeding, let's say, 11,000 SHU? Let's say it's a 55% chance. Or maybe this is a bimodal situation. Maybe we have a whole box of peppers. Some of the peppers came from one part of the country, another box of peppers came from Mexico. I don't know. Maybe some of the peppers, just based on the soil that they grew and have a different spice level than others. So maybe it's a bimodal situation. Hopefully, as you can see, I've only made this more complicated and more confusing than it really needs to be. And the reason why is because there's a really key missing element to our forecasting problem here, and that is context. And the context in this particular case are factors that may impact the spice level. So for example, how big is this pepper? Is it the size of a giant bell pepper, or is it about as small as like a quarter? That matters, doesn't it? How long is it going to be in contact with my mouth or someone else's mouth? Is this going to be something you can chew and swallow really fast, or is it going to be something you have to really chew on? It's really tough and it's in your mouth for like 30 minutes. That definitely has an impact on the spice level, right? Are we eating this right after eating a serrano pepper? Do we have some sort of context, some prior event that's going to help mold our estimation of the spice level? Better yet, do we have some sort of mitigating factor? Do we have a glass of milk nearby that can help mitigate the spice right away? All of these factors are really important. And that number all by itself, 10,000 SHU or 12,500, or all these probabilistic numbers really don't help. The reason why is context is the missing link. And that's going to be a theme as we go through the presentation today is how do we message information, numerical information, whether it's deterministic or probabilistic? And the answer is we need to have some sort of context. So there's three main obstacles, I believe, to communicating forecast information, especially numerical forecast information. And we're going to talk about each of those today. The first obstacle are words of estimated probability. A lot of us are probably familiar with that. And then a couple of newer terms or newer ideas, words of estimated intensity, and what I like to call naked numbers. So what we're going to do first is we're going to jump into words of estimated probability. So what are words of estimated probability? Well, they're just that. They're words that to estimate a probability. So instead of saying 50% chance, we use a word in its place. And examples of these include low, medium, and high. Those are the obvious ones, but less obvious ones, such as possible, probable, chance, likely, uncertain, perhaps. Those are all part of our normal, if you want to say your weather diction, it's in our lexicon. It's the words we use all the time, especially the word possible. Now, examples of this are there's a low chance of thunderstorms today. How many of you have said something like that? I know I've said something like that. Another example is snow will likely change to rain and freezing rain tonight, likely being that word of estimated probability. Or winds greater than 50 miles an hour are possible overnight. This sentence actually has a lot of potential obstacles to communication, but right now the word possible is what we're focusing on. That's the word of estimated probability. And the reason why words of estimated probability are confusing is because the public and partner perception of words of estimated probability, they vary and they cover a much larger range of probabilities than we intend. And just to exemplify this, we're going to show figure 5 from Lenhart et al. 2020. A lot of us have probably seen some sort of figure like this, whether on Twitter or Reddit or some other social media site. What this is showing is on the left-hand side, those are different words of estimated probability. And they surveyed a group of people to basically pinpoint a probability based on that word. And that's shown on the x-axis. What you can see here is the four words that they're choosing to show in this one figure: expected, possible, may, and chance. They all range from 0 to 100%, especially that expected word. When I say expected, I'm typically like expecting something to happen with almost 100% certainty. But a large group of people assign that a 50% chance. In the National Weather Service, we talk about likely pops, the likely chance of precipitation that starts at what, like 55, 56%. Well, that's right in the middle of this plot here. You can see no matter what the word is used, everyone ascribes a 50% chance. So that word likely, it's a word of estimated probability, is not a good word to use. So this is really confusing. And to hit this home even more, some of you may be aware of the SIRS assessment that was just released yesterday from Hurricane Ida in 2021. It just devastated part of Louisiana and actually went into track all the way into the northeastern coast of the US with deadly catastrophic flooding in New York City. And one of the key findings was that using words of estimated probability, or WEPs, it's a serious communication challenge to the information receiver, whether that's a partner or the public. And the reason why is because WEPs are subjective and they can be interpreted differently than intended, in that case, differently than what the National Weather Service expected. And a key finding directly after this fact was that core partners, particularly in the Northeast around New York City, misinterpreted the forecast. And that's because they didn't fully understand how severe this event would become. A large part of that because of words of estimated probability. So this is a problem that faces not only the National Weather Service, but really all meteorologists, and I would argue everyone in any science field. That's a real challenge. So I have 5 strategies here on what to do with words of estimated probabilities, strategies to use if you do have to use those words, or just how to avoid them entirely. And this is all based off of social science research too. I've done my homework here. I continue to do my homework because this is really fascinating to me. But one of the first things that's recommended is to provide some sort of accompanying percentage or some sort of numerical context. And that word context is going to come up a lot this afternoon. So for example, there's a low or a 5% chance that snow totals will exceed 8 inches. It's still not a perfect phrase, but you're providing some sort of numerical context. Another example, we have high confidence, greater than 80% chance that wind speeds will exceed 45 miles an hour. So rather than leaving your user guessing what percentage you're thinking of, you're actually literally providing that information. Now, the second strategy is to use some sort of comparison statement to indicate relative probabilities, whether implicitly or explicitly. So example here is the probability of a tornado is lower than wind strong enough to down tree limbs. What would be even better is if you actually give the probabilities of each event occurring, but if you compare and contrast, you give some sort of context, what is higher and what is lower. Now, the third strategy, and this is one of my favorites, is to use a numerical ranking system. Instead of saying very low, low, medium, high, or extreme, just say 1 to 5. The numbers 1 through 5 are intuitive. 5 is higher than 1, so it must be a higher threat, right? And we use scales of 1 to 5 everywhere in our society, but especially in meteorology. Think of the Saffir-Simpson scale, the enhanced Vegeta scale. It's just a natural scale that we use for intensity already. So we can use this ranking system for all other aspects of weather, which we're going to talk about quite a bit in quite a few slides from now. Now, the fourth strategy with words of estimated probability is to simply state what you know. So a lot of times we get questions, especially in the Midwest in the winter time. Hey, I see model A or model B is putting out a foot of snow. What we'll tell them is, hey, this storm in question is still 2,000 miles away. It's off the coast of California. It has plenty of time for it to evolve. We simply don't know yet. Our forecast is going to become refined as the storm nears. That is far, far better than saying a snowstorm is possible, right? You give the information, you put all the cards on the table to the user, then they know what to watch. Maybe they'll check out the news that evening and see, the storms off the coast of California, and they can track that as it moves across the country. Another example is talking about thunderstorms. In the Great Lakes, we never have a pristine warm sector. It seems like we always have morning convection, morning MCSs. It just makes the forecast much, much more challenging. But a phrase we often have to talk about in our office is thunderstorms tomorrow afternoon or this afternoon. Depend on the coverage of storms in the morning. A higher coverage of storms in the morning means there's a lower coverage of storms in the afternoon. That gives our users something measurable, something they can look. They can look out the window and see. If I wake up in the morning and it's storming in the morning, hey, the weather service said if that happens, there's a lower chance this afternoon. That's simply stating what we know, puts all of our cards on the table, and it builds that trust with our users. Again, far better than saying there's a low chance of storms, severe weather is possible. I think this phrase, it's a little more wordy, but at least gives more context to the information. And finally, a lot of social science studies advocate avoiding these words entirely. And this is difficult. I still struggle with this myself. The word possible in particular, no matter what study you bring up, even if you look at the service assessment for the Hurricane Ida service assessment, the word possible was used. It was like an obscene amount of times, and they attribute that word directly to misinterpretation. So numerous studies advocate using or not using these words in particular. Possible, chance, if you don't have that percentage with it. Maybe, could, might, may, perhaps. Those are all phrases you want to avoid. Again, it's really tough. I struggle with it myself. I still catch myself using these words, especially possible and perhaps. But the science tells us we really shouldn't use these words. So that's the first section of the presentation here. That section always goes fast because it's a little bit more well-known, a little more established in the literature. But what I want to do now is I want to talk about words of estimated intensity. This may be newer to most of you, and this is, I think, more of a bigger issue in meteorology and really social or all of science as a whole. So what are words of estimated intensity? Think back to our peppers at the very beginning of our talk today. Words of estimated intensity are words that, even though they may have a well-established definition or numerical scale, the interpretation differs based off of individual perceptions and experiences and thresholds, right? So I can't tolerate spice. I used to when I was a kid. Something changed when I grew up and I can't handle any spice anymore. A jalapeno that would make me spit my food out. But you may be able to handle jalapenos or even serrano peppers. You may not feel much of a kick with those type of peppers. It doesn't mean any one of us are wrong. It just means we have different interpretations, different experiences, and different thresholds. So that is a word of estimated intensity. So how does this apply to meteorology in our jobs? So one of my core functions is to go on damage surveys after a particularly damaging or tornado event. And a lot of times we talk about the words minor, moderate, and major damage, or we use those words in other contexts, such as flooding. Now, the problem is those words are words of estimated intensity. So these are 3 pictures from a damage survey I was on. This was in 2015. An EF3 tornado struck Coal City, Illinois, the second tornado in 2 years that struck this community. And I have the pictures organized from left to right, generally from increasing severity. So as you go right, it looks like it gets worse. But what would you call minor, moderate, or major damage? The picture all the way on the left-hand side of the screen with the baseball field, sure, in the context of the rest of the path, it doesn't look that bad. Maybe we can call that minor damage. But what about the baseball team or the little league team or softball team that uses that field every Friday night? They can't play anymore. That's major to them. That's a huge disruption to their lives. What about the picture in the middle here? When you compare that to the picture on the right-hand side to the house that's completely demolished, sure, it doesn't look that bad, but if you were to call that minor damage right in front of the homeowners, would they be mad at you? That's almost insulting. That's still a major life event for them. So what is minor damage? When does minor damage become moderate damage? When does moderate become major damage? It's not clear, which is why we should avoid these words entirely. And by the way, there is a clear scale, the EF scale, that has damage indicators, which we use to estimate the wind speed, but still it's a word of estimated intensity. Another example, when we talk about winds, when does breezy become gusty and gusty become windy? This is especially true across the country. We all have different thresholds of winds. Strong winds in Rapid City, where Keith is, that may be very different to me in Chicago. It's always windy in the plains. If you ask someone from Oklahoma, what is a windy day? It's going to differ from someone in Chicago, the Windy City, which, by the way, the word windy has different meanings, right? So these words by themselves are estimated intensities. It's confusing. It opens the door for different interpretations, which is why it's an obstacle to communication. And one of my favorites, we're going to spend some time on this slide here. When we talk about light, moderate, and heavy, especially with respect to precipitation intensity, and a bonus is accumulating snow. But let's talk about snow for a moment. Even though we're heading into May, we're going to talk about snow. Anytime we're talking about light, moderate, or heavy snow, is it clear to our users, whether it's the public, the partners, what we're talking about? Here's 3 different examples or definitions of snow amount. All of them are correct, right? So are we talking about the literal weight of the snow? If you were to pick up a shovel, a snow load on your shovel and put on a scale, are we just weighing the snow? Are we talking about the visibility criteria? When you look at ASOSs, they define snow based on the visibility. They don't care, or they don't measure how much snow is falling at a particular time. It just looks at the visibility. What about the AMS glossary definition? That's on the top here. That shows snowfall amounts based off of amounts over a period of time. Each definition is technically correct, but when we talk to, let's say, a radio station or talk to someone at an airport, talk to a DOT, a Department of Transportation official, when we say heavy snow, do they know what we're talking about? I reckon they don't. The same thing goes for rainfall. When we say light rain, are we sending the message that someone can go outside without a jacket or an umbrella? I don't know about all of you. I've been out in some heavy drizzle, which is kind of an oxymoron in itself, but I've been out in some drizzle before and I've gotten soaked, even though there's only been 0.02 or 0.05 of actual liquid that falls out of the sky. So using the words light, moderate, and heavy, they're estimated intensities. It's confusing and it doesn't really get across the message that we want to send. So what are some strategies we can use for words of estimated intensity? The very first thing we can do is we can provide a measurable or visual benchmark with a context to time. And that last part, the context to time, is so very important, as we're going to talk about even later on in the presentation here. But when we provide a measurable or visual benchmark, that's something that we can literally visualize or see with our own eyes and be able to make some sort of action or take an action. So for example, low-hanging fruit, we can say 1 to 2 inches of rain are going to fall every hour. That's something that literally someone could put out a rain gauge or measure it. Same thing with snowfall. They can stick a ruler outside and they can measure the amount of snow that's falling. That's so much better than saying heavy rain or light snow. Another example is when we talk about river flooding. Right now, the Mississippi River is in major flood stage, really from La Crosse all the way down to Davenport. Minor, moderate, and major flood stage. What does that actually mean? It's actually confusing to me, and I think we really need to change our terminology there. I think it's far easier to tell, let's say, a member of the public, someone who lives along the river, or an emergency manager, hey, the floodwaters are going to reach the end of the pier. They're going to reach, 5th Street. They're going to reach, this landmark, the library, by tomorrow morning. That is a lot easier to understand than saying major river flood stage. And that is information someone can take and make some sort of action based off of that information. And another really common one, especially in the Great Lakes in the northeastern United States, is to talk about tree damage. When we say strong winds, what does that actually mean? Did you know that a tree can fall or snap or get uprooted and its wind speeds as low as 45 miles an hour? If it's an unhealthy tree or if it has shallow roots, it doesn't take much wind at all. But the same kind of tree damage can occur in 100-mile-an-hour winds. So we're already having a problem with wind speeds, different numbers, but also different intensities, right? Strong, breezy, gusty. It is far easier to say, hey, the winds are going to be strong enough to knock down a few trees. That also gives us a little bit of room in case the forecast doesn't quite pan out. Maybe instead of 80-mile-an-hour winds, we see 50-mile-an-hour winds. We may still see a few tree limbs down, but maybe they're not as widespread, but the tree limbs are still down. That's the context, that is the impact, and that's really what we want to message. So the first strategy to avoid words of estimated intensity is literally to provide that measurable or visual benchmark with that context to time. Now, the second strategy is to refer to a well-known or past storm event for comparison. And I think a lot of us are aware of this and have heard of this. But for example, anytime there's a line of storms coming from the Midwest, especially after the past couple of years after the big derecho, we get a question: is it going to be as bad as that one storm last August? And it's really easy to say, no, the storm's not going to be that bad, but we're still expecting down tree limbs and some power outages. We're not ascribing it intensity. We're not saying it's strong or it's severe. We're just saying it's going to be, not as bad as that storm, but still produce some damage. Another example, especially in the winter time, we get a lot of questions about the 2011 Groundhog's Day blizzard in the Chicago area. That's sort of the modern day benchmark for a huge blizzard. But it's always good to compare storms to that storm as well, because if we were to go out there and say, hey, this storm's going to be as bad as the Groundhog's Day blizzard, you can bet you every single store is going to be closed. All the shelves are going to be cleared out and the schools are going to be closed for a week. It's because they know that event was crippling. It was horrible. It took literally the city of Chicago a week to dig out. So if we provide that really well-known past storm event for comparison, people instantly know what to expect. One final example here, especially as we get into the warm season, we get a lot of questions about storm intensity. A phrase I like to use is, this storm is going to be like your average summer storm. You're going to have downpours, lightning strikes, maybe even some small non-damaging hail. You tell them exactly what to expect instead of saying, it's not going to be severe, it's not going to be strong, or you're not going to have heavy rain, right? You're literally telling them what to expect, as well as drawing a comparison to like a past or a typical event. Now, the third strategy here is to simply state what you expect to occur. I'm not sure why my email opened there. I'm sorry about that. My email is misbehaving here. Simply state what you expect to occur. So an example of this is to say it's going to sprinkle on and off all day, so keep a rain jacket handy. That is far better than saying there's going to be light rain today, because if you say there's light rain, someone may just go outside without an umbrella. Literally tell them what you expect to happen. Keep that rain jacket handy. That's a phrase I use all the time in our products here at NWS Chicago. Another example is damaging winds are going to lead to widespread prolonged power outages. That's a lot easier to understand than saying a high wind warning is in effect, or we're expecting 80-mile-an-hour winds. And by the way, just taking a step back, if you put a group of meteorologists in the same room and watch the same video or same storm, they're all going to disagree on the wind speed. So if we can't agree on the wind speed, why are we trying to have the public do that for us, right? It's far better to tell them the type of impacts to expect. We're expecting tree limbs to be down, trees to be uprooted. Maybe we're expecting structure damage in a day like today. That's information that emergency managers, our partners, and the public can use. One final example for this particular strategy, and this is so true in the wintertime, is just to say roads are going to be icy in the morning. I'll be honest here, and I'm not trying to be negative. I don't think the public can tell the difference between sleet, freezing rain, graupel, snow. Sometimes it's difficult. Sure, we can have a better education campaign, but I don't know if it really matters. An inch of sleet is sometimes worse than a half inch of snow, right? It is far better to say the roads are going to be icy. I don't care why they're icy, they're icy. And that is the information people can use to improve their lives, whether they're leaving for work earlier, they're not going on the roads at all. If they're able, they're working from home that day. That is information that's easier to interpret than saying we're going to see 2 to 5 inches of snow tomorrow. There could be some sleet mixed in. Oh, and by the way, maybe some freezing rain. Those weather grids that are just completely messy. I think that's a disservice completely. We really should be focusing on the impacts. Now, I want to spend a little bit more time on words of estimated intensity here, in particular, talk about the categories of like an SPC outlook, marginal, slight, enhanced, moderate, and high. Meteorologists, we feel pretty comfortable with these words since a lot of us are familiar with the Storm Prediction Center outlooks, but the reality is these words are words of estimated intensity. So a lot of you have probably seen this nifty chart that the Storm Prediction Center has. This is how they convert their probabilities to different outlook categories. You can see that for each specific hazard, whether it's a tornado, wind, or hail, the outlook categories are actually different based on the same probability. So for example, a 15% chance for a tornado is considered an enhanced risk, whereas that's a slight risk for wind and hail. So that's a little confusing to begin with. But what about the Weather Prediction Center? They also produce outlooks for excessive rainfall. And that phrase by itself, excessive rainfall, is an estimated intensity. So that's already problematic to begin with. But look at their outlook categories. They only have 4 categories. They don't have enhanced, and their probabilities differ from the Storm Prediction Center. Can't forget about the Climate Prediction Center. They also produce outlooks based on temperature and precipitation for the extended range, as short as 2 weeks to as long as months in advance. They only have 3 categories, and surprise, surprise, the probabilities are different. Oh, and by the way, the colors are different too. A slight risk is light blue, a high risk is this purplish color. Well, the Storm Prediction Center, the Weather Prediction Center, the Climate Prediction Center, all part of the National Weather Service, yet we have these different criteria, different categories, and different scales. So the question I want to pose to all of you is, where does 30% fall in all of these outlooks? Well, for the Storm Prediction Center, that can be a moderate, enhanced, or a high risk, depending on the hazard or depending on whether it's supposed to be significant. That's confusing. With the Weather Prediction Center, that falls into the moderate risk category. Well, 30% for the Climate Prediction Center is somewhere between, oh, I have it wrong there. It should be somewhere between slight and moderate. So that's confusing in itself as well. And let's go back to the 2021 Hurricane Ida service assessment. Another fact that they identified was that graphics and NWS briefing packets use similar colors, but with different meanings. And the example they used in this particular example was looking at hydrographs of forecast stages of a river level, as well as the word limited. That's a word of estimated intensity. That probably referred to a hazardous weather outlook. And another finding was that the assessment team could not find any standard standard scale or consistency with color bar ranges when presenting confident risk, impact, timing, or threat information. And they actually pulled out a specific example of the Coast Guard misinterpreting a forecast because of our inability to have a standardized range. This is a big problem, a really big problem. And this really ties into words of estimated intensity. So what are we supposed, well, really, what should we do? Not all hope is lost. There's some things we can do. Oh, one final thing I wanted to mention, the public perception of categories also differs from our expectations too. Studies have shown, and numerous studies from different authors of different methods, have shown that the public perception goes from slight to marginal to moderate to enhanced to high. So that's not exactly what we're intending either. And the reason why is these are words of estimated intensity. So the recommendation here is just to use a numeric scale, just like what we were doing for the words of estimated probability. You want to use a scale from level 1 to level 5. It's a lot easier to understand. It's a lot more intuitive. So rather than saying there's a slight risk for severe weather, we quite literally say there's a level 2 out of 5 threat for severe weather today. And excuse me, this really should extend to all aspects of weather too. It shouldn't just be severe weather or flash flooding. It would be really neat to have National Weather Service, or really the weather enterprise as a whole, speak to weather threats on a ranking system, no matter what's actually causing the weather. So let's say I have a big willow tree outside my window here. Let's see my big willow tree falls. It's not important to me what caused that tree to fall, whether it was a tornado, whether it was a thunderstorm, a microburst, a sting jet. What matters to me is I have a tree I have to pick up. And what would have mattered to me is the relative threat level that tree would have fallen, no matter what actually caused it. So whether it's a sting jet or a winter storm or a severe storm, saying there's a level 2 out of 5 threat for that tree to fall is much more helpful than saying severe weather. But I think that's probably a decade down the road. We're not quite there yet. All right, so we've talked about words of estimated probability and words of estimated intensity. Let's switch gears and talk about naked numbers. And these are also a huge obstacle to communicating weather information. So what are naked numbers? What I'm going to do is I'm just going to throw a bunch of numbers on here. We're all meteorologists on the call, so we can probably use our intuition to figure out what some of these mean. Something probably is a wind speed. There looks like there's a temperature up there. It looks like there's maybe a snow amount up there, maybe a ratio of some sort. But these numbers by themselves, it is impossible for us to determine what they are, right? Well, here we go. I'll toggle on what they actually are. So there's a snow amount, a wind speed. How many of you guess the wave height or the hail size, right? So those numbers just by themselves, this is an extreme example, they have no context. It's impossible to interpret them. So words or naked numbers have no context. They mean different things to different users. And they're also really easily misinterpreted. And we're going to go over some examples of exactly how. But naked numbers also encourage users to focus on numbers rather than the feelable impact. And a real poignant example of that, I pulled this from last year. The Tampa Bay Times had a fascinating story talking about how forecasters at the National Hurricane Center were worried that people were not taking hurricanes as seriously as they should. And this was in context to a storm that was approaching the US coast. And they highlight that American can measure and fear storms by wind. And that's in the context of hurricanes. I say this goes for all types of weather. How often do you see a winter storm headline saying up to 20 inches of snow is expected in Minneapolis, or up to 80 mile-an-hour winds are expected in Derecho in Dallas, Texas? By focusing on those numbers, we're actually drawing attention away from what matters and focusing on something that frankly is arbitrary. And this is a big problem. In the context of hurricanes, peak wind speeds are not the only indicator of impacts or flooding. Think back to Hurricane Katrina. New Orleans was not hit by the eye of that storm, yet it was the hardest hit area where most of the deaths happened because of flooding. Yet the Saffir-Simpson scale focuses only on wind speeds. It doesn't really make sense, does it? So when we talk about naked numbers, it's numbers without any context. We're drawing attention to the wrong part of the forecast. We're looking at numbers, arbitrary numbers, rather than the feelable impact. And that's why it's such a huge obstacle to communication. So let's bring this back to snowfall. I know we're talking a lot about snow. It's just so easy to use snow for these examples. Let's say we're forecasting a winter storm in Chicago. Okay, and let's say we have 4 forecasts. Each forecast is basically updated every 12 hours. The first forecast is for 3 to 6 inches of snow. The second forecast is 3 to 5, so on and so on. Each of these forecasts seem like they're pretty close to me, but does this give the false sense that the forecast is changing? As we go from 3 to 5 inches in forecast 2 to 4 to 7 inches in forecast 3, does that seem like we made a huge jump? In the grand scheme of things, 2 inches is nothing. And kind of using context clues, if most of this is falling within, let's say, a 12-hour period, that 2 inches is really not going to make a difference at all. But by having these different snowfall ranges, these different what we call naked numbers, we're given the false sense that a forecast is changing. What if we had 4 different forecasts from 4 different entities? So let's say the National Weather Service, the Weather Channel, IBM, and AccuWeather. Again, they're all sort of in the same neighborhood, generally 3 to 7 inches. But by having 4 different ranges from 4 different parties, that gives the sense that we don't know what we're doing because we all have different ranges. Again, the impact is pretty much the same, right? Well, what is missing here? There's really key elements that are missing here. The water content of the snow, the snowfall rate. Is this snow falling within, let's say, 12 hours, or is it falling within 2 hours? That's a huge difference, right? The timing of the snowfall. Is this at 3 a.m. on a Saturday morning when road crews can clear the roads, or is this going to be falling at 4 p.m. on a Thursday afternoon when everyone's going to be on the road at the same time? Their duration related to the snowfall rate. 4 inches of snow that falls in 1 hour is very different than 4 inches of snow that falls in 12 hours or even 24 hours. The temperature also matters. Snow really struggles to accumulate when the temperature is greater than 32 degrees. Snow that falls in April rarely accumulates unless it's nighttime. The sun angle cuts through the clouds, right? So that information is also critically important, as well as the wind speed and the direction. What's the visibility going to be like? If we're just focusing on the snow amounts, 3 to 5 inches of snow, all of this information is missing. We're also training the public and our partners to ignore this other critical information since they're looking for the snowfall amount. Well, you may go back and say, guess what, Brett? The National Weather Service is going in the right direction here. We're going to be looking at probabilistic information. That's going to be the panacea. So why don't we have a probabilistic chance of exceeding 4 inches of snow? This is going to solve everything for us. Guess what? All that information is still missing. All we've done is, I think, made the forecast more confusing. We need this context in order to bridge that connection from deterministic or even probabilistic information to an actionable forecast. And guess what? There's even more information that's included in probabilistic information that's missing. So, for example, is there a difference in location of the heaviest snow axis? Why is there a variance in the models, right? Is there a difference in the snow ratio, the water content? Is there a difference in the strength of the system? Going from a deterministic to probabilistic forecast, I'm going to be blunt here. It doesn't solve anything. We need to add that context. And I would even argue that a deterministic forecast with context is better than a probabilistic forecast. If we're able to add the context to a probabilistic forecast, then we're cooking with fire. Then we're doing really well. So how do we do that? Well, let's just take one more example. Let's take a step back, get out of meteorology for a minute here. Let's say you woke up this morning or you wake up tomorrow morning with a stuffy nose, a sore throat, you just feel really, really sick. You call up your doctor says, all right, come on in, let's run some tests, let's run some blood work. All right, let's say after a few days, you get your blood work back. These are typical counts that you get back for blood work. I don't know what any of it means. I'm not a doctor, I'm a meteorologist. I don't know what cell per MCL means. I don't know what unit that is, but these numbers look pretty big. I think they're okay. I don't know. Let's add some probabilistic information. Let's say these are the IQRs, the 25th to 75th percentile white blood cell count is 4,500 to 10,000. I have no idea what that means. I don't know if that means I'm getting sicker, if I'm healthy. I just don't know how to interpret that. When you call up your doctor, what happens if they say you have a 33% chance you have cancer? Oh my God, I have no idea what to do with that information. My life just changed, right? No, that's not what your doctor is going to do. What your doctor will do is they will say, okay, first let's give some context, okay? These numbers are mostly normal for your age, for your gender. This is where you should be, right? Except one of the key critical elements, the hematocrit, I should have known how to pronounce that before the talk here. That's a little bit low. So what your doctor is going to tell you is based on your blood work, your family history, and your diet, so context, you may have anemia. This is how you're going to feel. You're going to be tired and sick until we address your condition. And here's our plan, right? So that's how our doctors use their test results in order to inform their decisions. Now, here's the thing. Doctors can share those test results with other doctors. They can use that information, the red blood cell count, the white blood cell count, and share it with their colleagues to make informed decisions, just as meteorologists can share that information with others. We can understand the numbers, but they're not necessarily sharing that with the users, the people who are actually sick, because that information doesn't help them, right? It's the same thing in meteorology. So whenever we're using deterministic or probabilistic numbers, we have to add context. So how do we do that? There's three key strategies here. The first strategy is to provide impacts that typically correspond to the advertised thresholds. And you'll notice that these are all pretty similar amongst the different communication challenges. So for example, if we're expecting 60-mile-an-hour wind gusts, the 60 miles an hour by itself doesn't have any context. But if we add that context, these winds are typically strong enough to down tree limbs. Boom, you know what to expect. I always thought it's silly that in National Weather Service severe thunderstorm warnings, we lead with the 60-mile-an-hour wind gust with the call to action and the impacts really down low at the bottom of the warning. To be frank, I don't know who reads a whole warning out there. Maybe if you're listening to a NOAA weather radio, what we really should do is put the impact at the very top. This is a severe thunderstorm warning for down tree limbs. This is a severe thunderstorm warning for destructive deadly hail. That is a lot more easier to use than just some random number, whether it's 2 inches or 60 miles an hour. Another example here, when we talk about wind chills, a wind chill of minus 35, that seems pretty cold to me. But that doesn't give me any context to how soon frostbite will settle in, right? So it's far better to say frostbite will occur in as few as 15 minutes. Oh, and by the way, there's some regionality to this too, right? A wind chill of minus 35 in Alberta may not be felt as hard as a wind chill minus 35 in Kansas, right? We have to add that context, and the main context here is the impact of frostbite. The second strategy is to convey timing, climatology, and antecedent conditions. So for example, let's say we're talking about the probability of greater than 8 inches of snow. Let's say it's greater than 80%. If you add the last key, this is unusually high for our area any time of year, that instantly have your internal red flags go up or the alarm bells go off. This could be a really unusual event. So that is how you use probabilistic information to your advantage as you provide that sort of context. Another example here, although rainfall amount shouldn't exceed half an inch in an hour, that's a rain rate, that's already a good improvement. Any rain that falls on a burn scar will lead to flash flooding. Boom, that's huge. You instantly know what areas need to hone in on. A lot of times, at least the National Weather Service, will just post a map of the QPF forecast, the amount of liquid that's supposed to fall. And we use that as a proxy for flooding. And that information, that's all naked numbers. It's useless as far as I'm concerned. It doesn't tell you anything about the time of year, the antecedent conditions, any areas that's more prone to flooding, such as an urban area or a rural area. That's all context that we need to add. And it would be really great to just group that into some sort of threat level, like the enhanced rainfall outlook. Just call it a flash flooding outlook and say it's a level 2 out of 5. It's a lot easier to understand, right? And the third strategy is to consider whether you actually need to advertise numbers in your forecast, right? So let's say it's supposed to be really windy tomorrow. It's a word of estimated intensity, right? But let's say the winds tomorrow are going to be strong enough to move lawn furniture. Maybe a good idea to move everything indoors. I didn't have to tell you a wind speed. I just told you what's going to happen. And that's a lot easier to understand. Another example here, rather than talking about the snow rate, you can just say the snow is going to accumulate so fast that roads are going to become snow covered. So stay off the roads if you can. All that information is a lot easier to use to make informed decisions. Now, taking a step back, there is a place for numbers. There are thresholds that our partners use. A lot of snow plows, at least in the Chicago area, use 2 inches as a benchmark. If we get 2 inches of snow, they have to go out and plow. That's great. We can give them that information. We tailor the information to their needs. But that doesn't mean we need to do the same approach to everybody, just sort of blanket everybody with the same approach. And even taking another step back, I'm going to be pretty blunt here. I think right now I can't beat the models when it comes to forecasting. For the high temperature tomorrow, I can probably get within 3 or 4 degrees, but there's some models out there that are going to kick my butt every single time, and that is okay. But what I can do is I can provide the context to that temperature. I can say if I get a call from the city of Chicago, they get really worried about heat. There was a really deadly heat wave in 1995. If they ask me about a heat wave coming in, I can give them context about whether this is going to be a deadly event or nah, it's just going to be an average summer day. That's something that a model can't do. That is where our place is going to be in the future in the National Weather Service, and really the meteorology enterprise as a whole, is interpreting the forecast, using the model data and adding context to make it really usable. And that's why it's so great that you're all here today to watch this presentation. Oh, I forgot I added this. I dream of a day where I don't have to talk about snow amounts. Anytime we have a winter storm, I'll be frank, I don't care about the snow amounts. That's just one part of a huge laundry list of concerns I have that lead to impacts. So maybe someday we'll get there. So I'll wrap it up here. It looks like running just about on time. Keith mentioned at the very beginning that I have a quick guide here, effective communication tip sheet. If you just put your phone up to the screen, that should pull it up. It's a QR code. And we initially made this for the National Weather Association conference last year, so it's going to link to something that has the NWA on there. But this is a great tip and trick sheet that I update periodically that goes over everything we talked about today, and even has a few other tips and resources in there, as well as references. So if you're interested in this, check it out, bookmark it, let me know what you think. If you've also had success stories in your own careers or offices, let me know as well. The thing is, Keith mentioned I'm a subject matter expert. I feel like I don't know enough about this. I'm always trying to learn more and more about it because I think it's such a critical part of what we do every single day. I can't remember who said it. There's a quote that I'm going to totally steal here, but one of the greatest illusions of communication, or one of the greatest challenges of communication, is that the illusion that it took place. I mean, that is so true for meteorology. Even if you're the best forecaster out there, you nail the forecast every single day. If it's not interpreted correctly, it doesn't matter. Just be blunt, it doesn't matter. So thank you all for joining us today. And Keith, I'll think I have some time for questions here.
All right. Thank you so much, Brett. Yep. We do have about 15, 20 minutes for questions if anyone has any. There was Matt in the chat asked if you could post a link to that document as well.
I don't have it directly. Do you have it offhand, Keith? Otherwise, I can shoot it over to you.
I will be able to find it pretty quickly here. But okay, what I'll do while I'm searching for that, Lamont has it. Lamont always has the source to everything. So thank you, Lamont. Yeah, I guess I'll kind of start the conversation here, and then folks can either type their questions in the chat or just feel free to unmute and ask questions directly to you. I like your point about snow amounts there at the end as well. Out here, I'll be kind of frank. I mean, sometimes we're just guessing when it comes to measuring the actual snow, right? If you have really, really high snowfall ratios and you have a lot of wind, what are you going to do? It's just blowing around everywhere. It's tough to actually get an accurate measurement. So yeah, verifying those forecasts is just as difficult as making the forecast, I think. But I had a question, and this kind of ties into the IDA Service assessment, the confusion in the past and probably still with the Saffir-Simpson scale, and just trying to distill a lot of distinct coincident hazards that all have different preparedness actions. How would you recommend doing that effectively, I guess?
Yeah, that's tough. And I think back to when there's hurricanes as well along the Gulf Coast, you see like 30 different hazards, just like a hazard for every single different. There's like a storm surge warning, a hurricane warning, a flood watch. I mean, it's confusing and it's hard. And the best advice I can give is just to make it as simple as you can. What I always think about is, how am I going to explain this to my grandma if she calls? She's not going to understand the meteorology of it. That's because she's not an expert in it. But how would I explain this to her? And what we've had success in, at least in our office, especially with graphics, is just drawing really simple areas, just shading areas where specific threats exist. So a prototypical example for our areas, if we get a big fall storm, we're going to have a threat for lakeshore flooding. We're going to have a threat for maybe non-lakeshore flooding, just sort of flooding because of rainfall and rivers. And we may even have a threat for thunderstorms, and we may have a threat for, did I mention high winds? I may have not, but high winds. So what we will do is we'll literally draw out each individual area in a very simple polygon-based graphic and just put that in our messaging and let that speak for itself. We won't get really cute or specific with like specific numbers. Like I said, we'll rely on the strategies we talked about here. We'll say, wind strong enough to down tree limbs with power outages, the waves big enough to batter the lakeshore and flood parks. We just try to keep it simple. Now, if someone does need some really specific information, we can still provide that. It's just a one size fits all approach, putting everything on the table, every single metric, every single number just doesn't work well. But Keith, that is it's a challenge. It's a real big challenge. And it's something that I think the service assessment really brought to light. And I think something that as meteorologists, we really need to take a hard look at what we're doing and figure out what's the best way to get this done, because whether we like it or not, sometimes people's lives matter on it. And if we're not getting the information out there and conveying it effectively, then that can be the difference quite literally between life and death. And we need to be cognizant of that.
Yep, agreed. Let's see,
Oh, did
Matt
I
in the
answer
chat.
your question? Yeah, sorry.
What's that? Did
Did
you
I
answer
answer
the
the question?
question?
I'm not sure. Yeah.
I think, yeah, I mean, the acknowledgement is it's difficult and we need to get better at doing it. So I think this is one step in getting us closer to that. This presentation here and the tips that you provided, and just some of the research that's gone along with that as well. So Matt in the chat said really good stuff, like the overarching theme of context. Adam said that he noticed some offices providing more context instead of simply stating the hazard. We've kind of noticed that we've been doing a better job of that here as well. This tip sheet was actually part of our optional spring training this year, but we were trying to find on the social media team, we were trying to find some bad examples, right? Some good bad examples to discuss in our station meeting, and we couldn't find many because we're doing a better job of providing that context now. But yeah, I'm totally guilty of it too. I still use possible, I still use maybe, perhaps, whether it be public messaging or in my forecast discussions, and I feel bad doing that every time, but yeah, I still kind of lean on those terms.
And the other thing too, Keith, you sort of brought this up implicitly, and this was mentioned in the service assessment that just came out yesterday too for Hurricane Ida, is so it's a challenge, and there's been a lot of progress, at least in the National Weather Service. But one of the biggest challenges that was identified is consistency in messaging as well. So let's say there's a big winter storm coming through the Great Lakes, and let's say NWS Chicago does an amazing job with all the messaging. Everything's perfect, right? And it never works out that way. Well, let's say, and I'm going to pick on my friends up in Milwaukee. I know a lot of people who work up there. Let's say they message it. Need to message it with snowfall amounts. Does that conflicting message confuse the message? And I think it does. And I think that's a big opportunity, at least for the National Weather Service, but really for the weather enterprise as a whole, is to come together and figure out these are the things that we're going to message for this event. These are the main points we're going to reiterate. We're not going to focus on the snow amounts. We're going to focus on other things, and to have one unified message collectively. And I think that would be huge as well. But conflicting information, I think, is another challenge. You know, we collaborate headlines. We collaborate which counties are going to be in a severe thunderstorm watch or a winter storm watch, and then we go make our own graphics separately. It just doesn't really make sense, right? So I think that's another door for the future here, is collaboratively making our products so they're basically all the same, but just maybe showing a different part of the map. So yeah, I think the future is bright, and I think we are making great strides.
Yeah, there's some people concurring in the chat here. Adam says 100%. Lamont, big facts. Matt asked, curious, does CR Rock put together regional talking points or a more unified message?
Yes, they do, and I know in the service assessment that was a best practice, or at least a recommendations for the regional rocks to get more involved in the messaging and creating those unified messages. And I think that is helpful. But we also need to be cognizant of workload too. How long does it take to make those? Sometimes collaboration calls can take a long time. It's hard, but I do think that is definitely a step in the right direction. I think it's important to get buy-in. So if the ROC creates these best or these key messages, making sure that all the offices agree with them and use them versus just a few offices here or there. But I do see that as a good opportunity for regional operation centers, is to help craft those key messages. Even the key graphics, I think, would be pretty neat.
Yeah, definitely. And Matt followed up saying that Western Region does that as well, holds conference calls to get a more unified message. But he agrees about the time commitment as well.
Yeah, that's a stickler, is the time commitment. I think the eventual goal is that, as the models continue to get better, it's supposed to unlock time, but we're really good at finding ways to spend that time. So no such thing as freeing up time.
Let's see, I was going to see if anyone had unmuted. Lamont, looks like you unmuted.
Yeah, so really awesome presentation. Hopefully, can you all hear me?
Yeah.
Okay, awesome. Really good presentation. I shared I shared the Zoom link there in the pseudo chat room, the national one. But honestly, I think this is where we as meteorologists really struggle. I actually just went through a probabilistic exercise as part of our Western region. We have our ensemble fluency requirements, and really communication, I think, is an area that we really struggle. And, as meteorologists, if we don't have a specific threshold, we tend to just throw the kitchen sink at our partners, and they don't have time to really have time to digest that. So I think focusing on how can we best communicate this really complex information with context succinctly, I think is really I think that's the sort of training that we actually need. Obviously we're still learning more about some of the limitations of communicating probabilistic information, or just probabilistic information as a whole. But I think the communication aspect is something that we're not good at all. And so I think I would really love to see more sessions and training that focuses on, okay, how do we actually communicate this really complex information? Because I think, at least in my experience, I think that's why we see some hesitancy from forecasters to use it. It's like we don't know how to boil this down to where it's useful for our end user. And I think we really have to do that. So like I said, I mentioned to Keith in a side chat, I'll probably assign some of this as training to our forecasters, because I think there's an appetite for that. Like, okay, you want us to use this probabilistic information, but how do we actually communicate it? And as a SU, I feel like that aspect. You may think communication is a WCM thing, but it's all of us. So I think that aspect is what we really need to focus on going forward. So well done, and hopefully, I don't know how much of this you've shared with the STI chiefs at the different divisions, but if not, I absolutely think that I think we need to do that for sure. Just my opinion.
Well, thank you, Lamont, and great points too. And I'm glad you brought up that it's not just a SU job either to talk about probabilistic information. It's really a whole office concept, but especially with WCM's warning coordination meteorologists, being able to learn about our partners and what their personal thresholds are is so critically important. And just for an example of that, in NWS Chicago, we have the responsibility for taps for Chicago, O'Hare, and Midway. I know that they're not going to care if the wind direction, all they care about is it west or east. Does it have that kind of component, right? So if I get a call from O'Hare Tower, I can anticipate what their question is going to be. I can anticipate the information they need. And that's because we put in the work to learn what their thresholds are. So that's a key part of this. So I'm glad you brought that up, is that we really do need to work with our partners to figure out what information do they need, what information do they need that they don't know they need yet, right? It's kind of a circle, but that is just such a key part of it, because once we can tailor it to their specific thresholds, to their needs, that really helps us provide that context. But yeah, thanks for bringing that up, and all great points. Thank you.
All right. Yeah, in the chat here, Adam is clamoring for more training, please.
I want more training on it too. I'm with you.
Matt mentioned that their forecasters don't fully grasp probabilistic guidance and what it truly means. And if you don't understand, how can you support your partners with proper messaging? Do you want to touch on that, Brett?
I mean, it's amazing. So I guess I'll take a step back. There's something in computing world called like Moore's law, right? So every 2 years, computational speed is supposed to double. The probabilistic products that have come out, even in my short career, I joined the Weather Service in 2017, so it's almost 6 years now. I mean, it's like night and day. You have things like the EFI tables, cluster analysis. I mean, a lot of this is like really like upper level statistics, especially cluster analysis. I mean, we're talking about like empirical orthogonal functions. That's like upper level stats. It's getting increasingly complex to be able to interpret that. And you're absolutely right that if we can't understand it, then we can't provide the context. But at the same time, as more and more information becomes available, and I'm thinking also to the warn on forecast, there's so many different products in there, it's hard to know what to look at. We need to be careful not to have too much, and being able to identify what are the most useful products, and what is really going to give us the most signal is a challenge in itself. And I think especially for all the SUs on the call, that is a great challenge for all of you too, because you're sort of the interface from the research world and being able to get that information down toward the more operational staff. That is another challenge. Again, I think the future is very bright. I've been watching Warren on Forecast the past few days. It's been like nailing some of these like right turns with supercells. That is incredible to me. But you also have to know which products to look at, right? So I think that is another kind of, if you want to say a double edge to the sword with probabilistic information, is you got to know what to use. You have to be able to understand it, and you have to be ahead of the curve.
Yep, for sure. Yeah, and Lamont mentioned that the machine learning aspect of WAFs is scary good. Also.
It is. Even look at the CSU probabilities from Russ Schumacher's group out at Colorado State. That will. I hope there's no one from SBC on here. I'm not putting them down, I promise. But that kicks their butt out like day 5 through 8.
It does, Brett. You're absolutely right. I had this same conversation with Matt Jeglum, who's the deputy STI chief, and they're using, and I don't know exactly how everything works, but in terms of kind of, I guess their base model, they're using some sort of really coarse resolution model, and yeah, they are doing very, very well, and kind of like, as you mentioned, more skillful than the human SPC forecasters, who I have an immense amount of respect for. So
Yeah.
that machine learning AI type stuff, I've been using like Chat GPT to help me with some of my programming. It's just absolutely crazy, like how good it is.
Yeah. And I'm glad you brought up the point about the SPC forecast too, because I mean, they have an immense amount of experience. So it's not an us versus them. It's not machines versus humans. It's how do we use it together, right? So how do we use those machine learning props to make those, to add that context and provide the extra lead time is really the opportunity. And that is kind of a cultural, a key subtle cultural element there, is being able to use the information to our advantage. But yeah, the future is really bright. We just have to make sure we know how to use it.
All right, we got a couple minutes left in the hour. Anyone have any final questions for Brett here? If not, there's one thing one prompt I'll give you, and I'll let you kind of finish things up here. But big focus of the National Weather Service is impact-based decision support services. Maybe we're getting better at that with our core partners. How do we translate that to impact-based public messaging? Now that our communication with the public has changed so dramatically in the last 10 years or so, where we have those direct two-way conversations now via social media and other platforms. How do we get to that?
That is a very difficult and great question, Keith. Great last question. A few ideas that come to mind are, number one is, the infrastructure has to be there to be able to display information properly. So everyone has an app on their phone these days, right? A weather app. And if you go to the Weather Channel website, even AccuWeather, any other website, their website interface kicks our butt, National Weather Service's butt. So we really need to get better with that. Find creative ways to display the information, because at the end of the day, we're not going to be able to get to the 300+ million Americans. It's just not realistic with our workforce. But we should be able to have, whether it's harnessing AI or some sort of machine learning, to have innovative visualization tools that someone could very easily interpret a forecast. I think is a really key part of that. Now, the flip side of it too is our partners should be ambassadors to a local society, right? And this gets into working with underserved communities. That's a huge area we really need to work on in the Weather Service. And obviously the headquarters leadership are jumping on it. But for right now, until a more formal policy is in place, our partners are the local ambassadors, and they're the ones that we have to rely on to help interpret that information to their own public, whether that's through some sort of next door notification or public phone alert system, or getting down with local churches or community groups, volunteering groups. I think that's sort of the way we have to go right now, at least with the underserved communities. But again, I think a huge part of it is developing those web-based tools that just make it really easy to understand visualization techniques to reach the public. At least those are just some initial thoughts, Keith. It's hard. It's really hard.
Well, we'll have you back here in about 6 months and we can discuss that further. How about that?
Yeah, perfect. Sounds good.
Thanks so much, Brett. It's always a pleasure hearing from you. And this talk was or is being recorded. I'll try to get it up this weekend. So if you all want to share the links far and wide, you'll be welcome to do so at that time. But thanks again, Brett. And I think we'll have, so next month, we're going to actually have a panel discussion on some mental health challenges associated with operational government meteorology. So look out for the details on that. They'll be coming across our social media feeds here in the next week or so. But Brett, thanks again. Thanks everyone for joining, and we'll see you next time. Have a good weekend.
Thank you. Have a good weekend.